Hello and welcome everyone. So we are launching today a new series of simplifying optics, very much important for students studying in intermediate, secondary and graduation level. It's been a long series, so we're good to go. So in part 1, what's our agenda? So I'll explain what's our agenda is. In the part 1, we will be dealing with the basic terminologies. What terminologies we are going to need? Okay, unless and until you know the basic terminologies, okay, you cannot understand or you cannot digest the concepts of optics. Okay, so what are those basic terminologies? The first very basic terminology that you need to know is what exactly is the frequency. Are you following it? What is frequency? Okay, from where does it come? How it's measured? What's its SI unit? We'll go deep into this and we'll make sure that you understand more precisely. Second one is what you mean by wavelength. What is the basic meaning of wavelength? How it's measured? And what's its physical significance? The third one is what exactly is a photon? Are you following it? And the last one is what exactly is light? Okay, what exactly is light? So this is our agenda for our lecture. So I hope we are good to go and we are going to start the lecture. So first of all, what exactly is frequency? Okay, what exactly is the frequency? So I'm not going into the definition directly. I'll go to the example directly. So that's why you can understand it more precisely. For example, here is a restaurant, right? For example, McDonald, right? So here's a McDonald restaurant. And this is you. Okay. So I'm considering you as a common man. Okay. So if this is a McDonald's restaurant, okay, very fancy restaurant. What at how many times you visit this restaurant? Okay, how many times you visit this restaurant? I can say a common man may visit at least say 3 to 4 times maximum. Okay, he can afford to visit there. So you cannot pay visit to McDonald's frequently. Are you getting this term frequent? How many times you can visit? Okay, getting it. The frequency is, I can say, low. The possibility of visiting this restaurant is low. Why? Because there are many reasons. Say budget is low. Okay, so and whenever you visit, you try to put status. Okay, you make sure that you people know that yeah, you are in McDonald's. Okay, now what we will do? We change the situation. Now this is your general stores, kirana store, right? This is your general store. Okay, what is the frequency that you visit? Say 10 to 12 times a month. Right? Am I right? 10 to 12 times a month. So whenever you go to this kirana shop, do you put status buying kirana, buying dal? No, you will never put. Why? Because this event is not so special because you visit frequently. Understand the term again, frequency. I'm adding this term frequent. Okay, getting it now. I hope you have understood this situation that every student's life student life will go across this situation, visiting a special occasion and visiting frequently. So what conclusion can you derive from this example? Frequency is nothing but a repetitive action. A repetitive action. Okay, a repetitive action or you can also know as a cyclic action or a cyclic action. When what is the rate of this repetition? If the rate of this repetition is high, means your frequency is high. If the rate of this repetition is low, the frequency will be low. Are you following it? Means, for example, if you are repeating a certain action, okay, the quantity of that repetition or the magnitude of that repetition is known as frequency. If the repetitive action is more, then the frequency is more. If the repetitive action is less, you can say that its frequency of this doing frequent. What do you know by frequent? You are doing it more in repetitive manner. Are you following it? Okay, so this is known as frequency. Okay, what do you mean by frequency? The rate of repetition or the rate of repetition or the rate of repetition of a cyclic action is known as frequency. So to define it in more technical terms, what we will do, we will form a wave. Okay, but this is the sine wave. If you don't understand sine wave, for example, this was a tightrope, and what I have done, I have just strung it like a guitar string. If you strung this, it vibrates in a sine manner. Okay. For example, see, this was the original position of the string. So if I make some kind of disturbance or induce some vibration, what it is trying to do? It's forming this kind of shape. Okay, means what it will try to do, this point, this for example this point will go up, this point will go down again. Okay, means what it's doing is crossing this, it's crossing this mean position. Are you following it? Another example will be like this pendulum. See, this is the pendulum, right? So if I make some angular displacement to this, okay, theta, and release it, what it will try to do, it will cross this mean position and it will come here again, right? Again it will, again what it will do, it will try to go in the opposite direction. Okay, so by doing this, what it is trying to do, it tries to cross this mean position. At what times it cross this mean position is known as frequency. What is trying to do, in fact it's trying to repeat its motion. Are you following it? Similarly, in when you deal with waves, the position, see the wave position is like this. Okay, the particle is displaced from its mean position. This is its mean position. What do you mean by mean position? Original position. If you're not understanding the term mean position, understand what is original position. So this was the original position, it's going there. Okay, again coming back to the mean position, again traveling over here. Okay, I mean what it's doing, it's doing a to and fro motion. So the rate at which the wave crosses its mean position is known as frequency, or the rate which it repeats its motion again and again at a certain point is known as frequency. Understand guys, to define frequency you need a reference point. Whenever you see the definition of frequency at against any case, there is always a reference point. Reference point means what? Frequency is measured with respect to that point. For example, this pendulum, understand this example of pendulum again. If the pendulum is oscillating, it's oscillating against its mean position. What is its mean position? Again I am repeating. Mean position means original position. What was this original position? Original position was right here when it was at rest. What it is doing? It's making an oscillating motion across this mean position. Means to attain oscillating motion, it needs to cross this mean position. Again, to have this sine function, to have this sine wave, the particle should cross this mean position or the original position. So what we are doing, we are referring to a certain datum. What do you mean by datum? A reference line. So this is the reference line, this is the reference line for pendulum, this is the reference line for wave. Are you understanding? So the rate of repetition against this reference or datum line is known as frequency. So we have defined within technical terms also. Now coming back to your example, here it was McDonald again, right? Here it was McDonald. Okay, here it was you. For example, if I am considering the door, considering the door of McDonald as a reference, how many times you have gone in and came out? Okay, are you following it? That is known as frequency. Okay, so if you are going at least 2 times a year, then your frequency is low. Means what? If you want to go inside, you need to cross this door. Are you following it? Okay, then or else you cannot put status. Okay, are you following it? What you will do? You will order something, you will click photos, put on status. Okay, but when you will do that, when you will cross this door, so if I consider this door as a mean position, then what will happen? Your frequency will be there. What is your frequency? Say 2 times a year you visit. Okay, are you following it? So this is a wave. The wave has to and fro motion. Okay, understand? It's known as a repetitive motion. See, the motion is repeating. Here also the motion is repeating. So at what rate the motion is repeating is known as frequency. Okay, so there was a scientist known as Heinrich Hertz. I will mention his name. Heinrich Hertz. There was a scientist known as Heinrich Hertz who studied what is frequency, and according to to honor his name, what we try to do, we always mention her frequency in hertz, Hz. Are you following it? Okay, so the best example of frequency, I'll give another example. What's the domestic supply in your house? Say 220 volt AC supply, and what's its frequencies? Frequency is nothing but 50 hertz. Are you following? 50 hertz. Okay, so I'll give this another best example. So what is the supply? AC supply. AC supply, you know, AC supply. In AC supply, the frequency in AC supply, the polarities changes. For example, at one moment it will be positive, at one moment it will be negative. Okay, getting it? Means in this, if this is your wire, if this is your conducting wire, and if I supply AC current in it, then what is going to happen? The polarities will be positive at in 1 second and negative at the other second. Okay, the polarities are going to change. That's why it's known as alternating current. It's altering its polarity. Okay, at what rate it is altering its polarity? 50 hertz. Means what? Means what? Understand its physical significance. In 1 second, the current will change its polarity 50 times. Are you following it? In 1 second, the current will be positive, negative, positive, negative. How many times? 50 times. Now, are you getting this concept now of frequency? So this is how frequency is measured. Okay. What this 50 hertz are trying to say? This 50 hertz is trying to say that this AC current means the electrons which are having polarities, with the current which is having polarity say positive, will change to negative, again positive, then again negative. See, this is a cyclic reference. This is a cyclic process, and this cyclic process will repeat itself in how many times? 50 times. So what is frequency? Frequency is nothing but the magnitude of repetition in 1 second. So how many times current will repeat itself? 50 times. Positive to negative and negative to positive. Are you following it? Okay. Another best example of frequency is say Radio Mirchi 93.5 Red FM. So 93.5. What you try to do? You try to tune your system to 93.5. Are you following it? Means the sound waves released at the radio station, and you will be at the receiver end. So here will be the transmitter, and here will be the receiver. Who is the receiver? Receiver is you. You want to listen to some songs. So the transmitter will transmit the radio waves with which frequency? 93.5 megahertz. Okay. So I'm not trying to explain you what is megahertz, what is gigahertz, what is kilohertz. Okay. So 93.5 megahertz. The transmitter, the radio company which is handling, what will try to do? It will convert the songs into sound waves. Okay. Sound wave at which frequency? 93.5, and it will release. And here you are the receiver. You are tuning your radio to 93.5. If you do 93.1, will you able to hear? No. Yes, you will be able to hear, but you will hear disturbance, and that disturbance is known as noise. Okay. When we will start sound waves, sound energy, I will explain you in much deeper. But understand this: 93.5 megahertz means what? The sound waves will be repeating itself. How many times? 93.5 million times. Okay. So I hope you understood what is frequency. So in case of light, understand this term frequency. The number of times the waves is repeating, because this is the motion of a photon. Okay, understand what is photon? We will going to see. So I hope you understand what is frequency. Okay. Now, so if you are understanding frequency, wavelength is much more simpler. What do you mean by wavelength? Okay. Wavelength, for time being, just understand wavelength is nothing but distance between two successive crest or two successive trough. So what is the crest? Okay, the crest is nothing but any displacement in the y direction. Any displacement in y direction is known as crest. Any displacement in negative y direction is known as trough. So this will be what? This will be trough, and this will be is known as crest. Crest is always above and trough is always below. So distance between two successive crests. So this distance is two successive crests. So this distance between two successive crests or two successive trough is known as wavelength. Wavelength is always measured in lambda. Understand? To be frank, wavelength is much more important than frequency. Understand it. What is wavelength? I will tell you with examples as we move on with the lectures. So for the time being, understand wavelength is always measured in lambda. Lambda is nothing but a Greek letter. Okay. Lambda is a Greek letter, and wave is represented by lambda, and it's measured in meters or Armstrong. Okay. Wavelength is always measured in meter or Armstrong. Okay. Understand this. Okay. So what is the SI unit? What you can say SI unit? SI unit, wavelength is always measured in meters or what I said in Armstrong. A superpower 0. So 1 Armstrong is nothing but 1 into 10 raised to minus 10 meters. Understand this. Okay. Wavelength can be measured in meter or Armstrong. Okay. So I hope you have got this wavelength. Wavelength is much more important. Okay, as we move on with the lecture, you will understand more about it. Now, very basic topic. What is light? Okay, so what is light? What is photon? That you will come to know. Okay, very basic topic. What exactly is light? From where it comes and where it goes. Okay, so first you need to understand this. So there are much more definitions of light. Scientists studied light for much more years, but they had some sort of imagination. What they tried to bring their imagination into their definition. But as the technology evolved, everyone knew what light exactly is. Okay, so we'll start. What exactly is light? From where does it comes? Okay, so the very elementary definition for light is nothing but it's an electromagnetic it's an electromagnetic wave. Okay, it's an electromagnetic wave, as well as it behaves like a particle at the same time, hence the term known as wave particle duality. Okay, so to understand this wave particle duality means what, light can act as wave and act as a particle at the same time. Are you following it? But the main doubt that comes here, what is light? Light in our sense, light means visible light. Understand this, visible light, the light which can be seen by human eye only, is defined in your book. Are you following it? Okay, the light which is not accessible to human eye is not defined anyway, is not used for you. Means on a broader spectrum, what we'll see, there is an electromagnetic spectrum over here. Okay, and out of which a very small amount of bunch we can see, which frequency ranges from 400 to 700 nanometers. Okay, now understand, 1 nanometer is equivalent to 10 raised to minus 9 meter. Okay, are you following it? Means see how much small is the frequency. So in the electromagnetic spectrum band, out of whole light, we can see only a small bit of light. Our human eye can detect only a small bit of light. That is known as visible light. Why it is called visible light? Because only this much amount of frequency, if the light is traveling with this much frequency, only and only then we are able to see. Are you following it? We means who? Human beings. Okay, cats, animals, dogs, and much more. There are much variety of biodiversity of animals who can detect even non-visible light. Okay, getting it? And whichever band I have drawn is known as electromagnetic spectrum. Understand this term, electromagnetic spectrum. Okay, so before defining defining light, what you need to do, you need to understand what is electromagnetic spectrum. So I already told you what is this. This is known as visible light. What is its frequency? 400 to 700 nanometers, and 1 nanometers means how much? 10 raised to minus 9 meter. So if you go right hand side, the wavelength, understand, wavelength will go on decreasing. If the wavelength will go on decreasing, means the distance between two successive crest and two successive trough will go on decreasing, means the sine wave will go on compressing. Okay, so here you have infrared vision, here you have X-rays, here you have beta rays, alpha rays, and the most important is gamma rays. Okay, nuclear radiation and everything. Okay, so if you see here, infrared ray, X-ray, beta ray, gamma ray, alpha ray, so they have low wavelength. Low wavelength means what? The distance between two successive crests and two successive troughs is very low, like this. Okay, if you form its diagram, it will be like this, bunched. So you can see the distance between two successive crests, two successive troughs are much more lower here. Okay, getting it? This infrared ray, X-ray, beta ray, gamma ray is not visible. Okay, you may have seen cats and dogs, you can even see in darkness. Can you see? Absolutely not. Why? Because their eyes can detect infrared rays. Are you following it? Okay, and if you go on left hand side, the wavelength will go on increasing. Here you have microwave rays, microwave radiation. Here you have communication rays. Okay, satellite rays, the communication rays or satellite rays which can be used for communication. Okay, as you go right hand side, okay, the wavelength also increases. Can you detect this communication waves? No. If for example, if you are on mobile, can you see the waves coming inside your mobile? Absolutely not. Why? Because it's outside your visible spectrum. Getting it? So what is this visible spectrum? Waveguide that you call as. Are you following it? This is known as waveguide. Okay, and in this topic we are only going to focus here. Okay, if you want to study higher, you can also go in infrared X-rays, how are they generated and what's its nature. But for the time being, what you need to understand, the wavelength will go on increasing. Okay, and here the wavelength will go on decreasing on the right hand side of the electromagnetic spectrum. Are you following it? So I hope you understood. So the very best conclusion that you can derive, that as wavelength increases, the penetrating power decreases, and as the wavelength increases, penetrating power decreases, but traveling power increases. Okay, means what? For example, X-ray. For example, if any patient who wants to have his or her own X-ray, what he tries to do? For example, here if this is the source of X-ray. Okay, and if I want to take X-ray of a hand, so the hand will be much more closer to this. The hand will be much more closer to this source. Why? Because X-ray has X-ray has low X-ray has low wavelength. Okay, X-ray has low wavelength and its penetrating power is more. Means what? It can easily cross through the flesh. Okay, but it cannot cross the bones. Okay, are you following it? So the penetrating power is much more. The X-ray, beta ray, gamma ray can penetrate through anything, but they can't travel further. They are decomposed on the place itself. Are you following it? Why? Because of the nature. So what you can derive? Wavelength, or you can say lambda, is directly proportional to traveling power. Okay, or traveling distance, and inversely proportional to penetration. Penetration means what? To pass through anything. Okay, so you write down this equation. Wavelength is directly proportional to traveling power. Means you can travel anything, and inversely proportional to penetration. Means what? X-ray, best way, X-ray wavelength is low. Okay, Okay, means what will be high? Penetration will be high. Yes, of course, because its application is used to see the cracked bones or the disarrangement of bones. Okay, so it can penetrate through a flesh. Okay, means penetrating power is more, but traveling, it cannot travel long distances, only few centimeters. Okay, so traveling power is less. Okay, another example of, say, communication waves. For example, your mobile waves. Say the wavelength is higher, but penetration is low. Penetration is low. For example, if you go in your storeroom, can you receive call? Absolutely not. The range will be less. But the traveling power, understand this term. The traveling power is much more higher. Are you following it? Okay. So this is the nature of wavelength. Okay, but we are not interested in this. We are interested in only and only visible light. So whatever definition you will come across is the definition of visible light only. Now, from where does this visible light comes? So understand, there is a particle known as photon. Okay, photon. So there is a huge misconception between photon and electron. Understand, photon are massless. Photon do not have any kind of charge. Means they are chargeless, they are massless particle, and they cannot be separated. Okay, they cannot be separated. So there is a basic difference. What is electron? And on the other hand, what is electron? Electron has mass. What is the mass? 9.1 into 10 raised to minus 31 kg. Okay, 31 kg. And they have a charge. What is their charge? Charge is negative. Okay, so this is the basic difference between electron and photon. Okay, so light or any electromagnetic radiation always have an elementary particle known as a photon. Now we are defining what exactly is light and from where does it comes from. Okay, so from where does the light comes from? So at a microscopic level, you know this is a proton, and these are its shell, K shell, S shell, M shell, right? These are its shell. For example, there is an electron in say upper shell. So this is an upper shell. So if the electron jumps at a lower shell, so this electron is jumping in this lower shell. So when it tries to cross these shells, what it tries to do? It tries to release a photon, which is an excited state. So this photon always carry an energy, and it travels in the form of waves, and this is nothing but light. Are you following it? Subsequently, if it receives this light, if this electron receives this light and gains energy, it will again move towards the upper shell. Okay, this is how light is generated. It's not definition of light. This is how light is generated on atomic scale. Understand this, on atomic scale. Whenever an electron jumps at a lower shell, from higher shell to lower shell, what is during this jumping, what it tries to do, it releases a photon. What is the photon? That I already defined you. It is massless and it is chargeless, but it is an elementary part of an electromagnetic radiation. So this light will be having frequency between 400 and 700 nanometers. As simple as that. If this light is having frequency between 400 and 700 nanometers, human eye can easily detect. If it is above 700 and below 400, human eye cannot detect it. Are you following it? So this was the answer for you, from where exactly light comes from. Okay, getting it? So this light can be defined as an electromagnetic radiation. Understand this, it's an electromagnetic radiation, okay, electromagnetic generated, and which has an elementary part such as photon, and it, while traveling, it electromagnetic means what? It has electric field as well as magnetic field. So light travels. I will show a 3D diagram, the wave particle duality. So while traveling, it also generates electric field. Light also generates electric field, and it also generates a magnetic field. Understand this. See, it also generates a magnetic field. So magnetic field and electric field are 90 degrees apart from each other. Okay, this is known as a dual nature of light. So light can also behave like a wave. Light can also behave a particle. As a particle, what is that particle? That is known as a photon. Okay, are you understanding? And what is the speed? The speed is 2.997 into 10 raised to 8 meter per second. Okay, now there is a lot more question. Can this speed be exceeded? To be honest, there is no satisfactory answer for that, because our universe is made in such a way that no one can cross the value of c. Okay, it's the maximum permissible speed. Now you can say that MPS, maximum permissible speed for any element, or any element, whether it be living, non-living, whatever, it cannot cross this value of c. Okay, why? The answer is not satisfactory. There are much more theories, but there is no satisfactory. You won't get any satisfactory answer for this kind of for this theory. Okay, the speed of photon is 2.997 into 10 raised to 8 meter per second. Okay, understand, but there is a limitation. There is no explanation why it cannot be exceeded, but there is a limitation to this. This is a medium based phenomenon. Okay, what is this medium? Medium is nothing but vacuum. Understand this. If the medium is changed, the speed of light is changed. Okay, understand. If this medium is changed, the speed of light will be changed. Okay, if the medium is changed, then light behaves differently. For example, if you are in certain situation, if you are in school, you behave differently. You cannot behave the same way as you behave in front of your teacher, or in front of your friends. You cannot share the information. You cannot share the same information. Am I right? Okay. The information you share with your friends, you cannot share with your teacher or with your parents. Why? Because the situation is changed. Similarly, light behaves differently when its situation is changed. For example, here see, if I change the medium, the speed is changed. Okay, means behavior is changed. Okay, so this gives rise to another phenomena, that is behavior of light. So light according to the situation behaves differently. Sometimes it reflects, sometimes it refracts. Understand this. Sometimes it diffracts. है ना? Sometimes it interferes. Sometimes it polarizes. Understand this. Okay, so when the situation is changed, okay, when the medium is changed, when the situation is changed, the behavior of light is also changing. See, sometimes it reflects or gives rise to the term known as reflection of light. Reflects gives rise refraction of light, diffraction, interference, polarization. Okay, so these are known as optical behaviors of light, giving the rise to the subject optics. Are you following it? So I hope you understood the basic terminologies. In the next lecture, we will be dealing with each and every behavior separately. Okay. Now, but the limitation of this lecture is what we will be only dealing with the visible light spectrum. Okay. This is a very vast subject, optics, but according to it, we will be dealing with only 400 to 700 nanometers of frequency. I hope you understood. If you have any doubt, you can comment in the comment box. Have a nice day.